Hi, welcome to workshop 3. And today's workshop will be looking at sensors. And the sensors we'll be talking about today are those that we'll be using during the practical section. So the outline of what we'll be talking about will include what a sensor is and the types of sensors. Most especially, we'll talk about the DHT11 and the SR501 sensors. These two sensors will also be used during the practical section. And we'll also look at some of the data sheets for these sensors and talk about what we need to do during the practical section. If you want to have an advanced knowledge of sensors, then we recommend this book for you. It has some important data sheets for sensors that are used for Internet of Things. So it is a good book for you to start with. Talking about sensors. Before now, you might have heard or seen one or more sensors within where you are. And you might have used one of them even. Now, sensor is a device that can capture, not only capturing, it can detect, and some can measure what they feel or see or observe within the environment where they are. So this information they see, observe, capture, collect can be used in different forms. They can be used as input to other sensors, or they can be used as an output that can show a direct result. So those, excuse me, for you to choose the sensor that you require for anything you want to do, there are certain things you have to consider. One of them is to consider the target. Knowing the target will help you determine the kind of sensor that you need. Knowing the environment where the target is will also be a kind of relevant information that will support your decision on the kind of sensors that will be required for the task. For instance, if you want to measure the temperature, then you might need like a thermometer. You might need the temperature and humidity sensor. If you want to measure human motion, maybe human hand motion, then you might need an SR501 sensor or even a visual sensor. Likewise in sound, if you want to measure sound, you'll be looking at sound sensors. Apart from knowing the target, you also need to define the measurement that you want. You have to know the kind of measurement you want to capture. So the information you want to capture, is it okay when you capture it directly? Or the information can be as an input from another sensor. So you should also try to know what principle should be used for detecting or measuring or capturing the information from the environment using the sensor. It's also necessary to know the required accuracy. Is it minus, plus? You need to know what the accuracy is. Then there is also a section that will be looking at the conversion of signals. If you have a signal or signals, what is the rate? What is the resolution? How are you going to convert it, and how will you validate the data? The last but not the least to consider is the kind of electrical pattern of the output. Is it going to be in DC or is it going to be in AC? And if they are going to be in these, what kind of voltage will be required, for instance? Or what kind of signal strength will be required? What kind of pattern will be required? So these are the things you need to consider for you to choose the best sensor to use in any of the projects you want to do. Like we always advise, it is necessary for you to know the kind of sensor and also know the data or more information like the specification of that sensor. And that could be found mostly at the data sheet. Now, let's move at the components of sensor. The three components of sensors, as we have stated here, is a sensitive component, conversion component, and basically the basic circuit. So the sensitive component is the part that is in charge of sensing the target. It can sense the physical, chemical, or even biological information of the target. And when these information are observed and collected, they need to be converted to the relevant state. For instance, if you have those information, they might not be in electrical form. So the non-electrical signals need to be converted to electrical signals, because you know that the systems you are going to run are in electrical or electronic form. So the signal needs to be converted to electronic form for it to be properly used in the system. Now, not only do you need to convert the signal, you also need to look at the required signal that you've converted, or the required signal for the component that you want to use. The component, I mean the circuit or the device that you want to apply those signals on. In this case, if the signal, for instance, is not is very low, then you might need to amplify it. So looking at this diagram, there could be a power supply at some point. Now, if we go to the next page, so this page is talking about the common sensory types. So these are about 6 common sensory types. The first is the gas, which can censor the gas within an environment. We also have a pressure that can censor the pressure of any device it comes in contact with. Then the humidity sensors the humidity of an environment where it is in present. The temperature can give an output of temperature of an object or the body or the environment. We also have the ultrasound and illumination. These are the different sensors that are most common ones. Talking about the illumination sensor, for instance, the illumination sensor uses the photoresistors to determine the output or how it's going to how is the resistors we're going to respond to the light. So once light shines on this surface, it regulates the resistance on the surface of the material, which is the cadmium sulfide. Now, if you look at the graph we've got here, you will see that when the excuse me, you will see that when the light, which is the illumination, increases and the resistance reduces. So when resistance increases, then illumination reduces. So this is the relationship between the resistance and illumination when using this particular LDR device. What causes failure? Sometimes you have your component wired, connected together, and you expect that they will work appropriately, but sometimes they might not work. And these are one of the things you have to take note of because they may sound very simple and very easy, which one may think I might not be, I should know all these and try as much as I can not to avoid them rather. But most of the times you will realize that little things are the things that cause problem, especially when you are working on some electronic components. One way or one thing that can lead to failure is inappropriate power supply. Let's assume you need 25 volts to drive a system, and the power supply you've supplied is just 3.5 volts. Then it might not be possible for that voltage level to run the circuit or the device because it's not the appropriate power supply. Another way to explain this is if you need, for instance, DC power supply and you are supplying AC power supply to the system, then it might not work. Another thing is when the out of working range. So the target could be, or even the environment could be the factor in this case. So if you have a device that can read the presence of the target between 0 to 10 meters, and the target is placed maybe 15 meters apart, then there might be challenge at that point. So it is good for you to refer to the specification of the component, which most times you can find in the data sheet, to know exactly what specifications the device can work with. And now, another thing that can cause the problem is environment. Sometimes the device might be, let's use this as an example again. So if you are sensing a device in an environment, sometimes the device might be within the specified range. But because the environment is not in a an environment is not really okay for the system, then the system might not work. I'll give you an example. If you have a device that's required to sense an object within 10 meters or 5 meters, for instance. So the device can malfunction if there are occlusion, like an object which is blocking that particular object it wants to sense. So this is one way an environment could be a challenge, or an environment can cause a problem or failure in the working of the sensor. We also need to talk about this wrong synchronization, which can come as a result of time interval not aligning, or even the electrical pattern not going properly as wanted. So another simple mistakes that we can do are the incorrect wiring and incorrect connection. So sometimes you might think that you have connected properly, not knowing that you have done wrongly in the connection. So these are some of the reasons why you see sensors failing at some point. Now let's look at this DHT11 sensor. The DHT11 sensor measures both temperature and humidity within the environment. In the sensory range, for temperature, it ranges from 0 to 50 centigrade. And the humidity ranges from 20 to 90% RH, pardon. So the accuracy is between minus plus 2 degrees centigrade for temperature and minus plus 5% RH for humidity. And the resolution is the same for both of them, 16-bit. And the working voltage is between 3 volt to 5 volts. Also have the output validation to be 40-bit data, and the last 8-bit are always the priority bit. The next sensor we talk about is the RS501 sensor. This sensor is used to sense movement in the environment, and the specification has the timer and the sensitivity. Also have the clockwise rotation increase. So there are two sensing component in this. One is the timer. So the timer is looking at the time delay adjustment, and we also have the sensitive adjustment. These are the two key things we need to consider. And if you look at this chip down here, you will see these two yellow button or yellow ports. So these two yellow ports are for adjusting the time delay and for adjusting the sensitivity. So the connecting pin for this sensor are the power, the output, and the ground. And if you remove the cap on the sensor, you will get these chips that are all managed within the sensor. Now let's move ahead. So for you to adjust the delay, or rather to increase the delay to the fullness, then you have to move or rotate the delay cap clockwise to the full. And when you do that, it takes about 5 minutes for the delay to come back live. Likewise, if you want to alter the sensitivity, then you need to either move it right or move it left, depending on how you want the sensitivity to be. You also have the single trigger mode and the repeatable trigger mode. The difference is the single has to, it won't continue detecting once it has the first detection. But for the repeatable time delay, it restarts every time the motion is detected. Now, this is looking at the DHT11, the reviewing of the sensor from the datasheet. So the datasheet will give you this information about the specification of the sensor, the working range of the sensor, the limitation of the sensor. This is the reason it is important to look at the datasheet before using the sensor, because it gives you very good information regarding the sensor. Also give you the measurement, the height of the sensor, the weight, and relevant information that you will need to know. Now, what are the things you expect to do during the practical session? So in the lab, we look at how we can read data from the DHT11 sensor using what you've got from our module. We'll also look at how we can read data from the SR501 sensor. So the data sheet is always available for you to refer to. Not only do we want to read sensors information, we would also want to do some little manipulation and make some smart configurations and connections using the attribute from those sensors. So these are basically what we'll be doing in the lab this week. It is always recommended that you be mindful of your connection. Please use resistors where necessary to avoid burning it. Avoid burning the device, I mean. So in conclusion, we have just discussed common types of sensors and also looking at the definition or describing what a sensor is. We have looked at the principles and reasons why some sensors fail. Then we looked at some electronic components and some conversions. So at this point, we are looking at the perception layer, which is talking about sensors. First, to use sensor to perceive and to listen from the environment. So here we're going to end this section. If you have any questions, please let me know. You can send an email or ask me some questions during the practical session. Thank you so much and see you on Thursday. Bye.